must think far beyond of what that nuclear power can do in terms of peace. Here we have a new source of energy, a source of energy that is absolutely important to the future of the world. That is why, as far as this particular matter is concerned in the terms of nuclear power, we must not be afraid. We must explore it.
The core thesis of Radiant is about prosperity for civilization, for every human, which means making power more affordable for more people. It's really just about enabling humans to be even more human. Power is the source and it is civilization itself.
The US lost its ability to iterate on nuclear power as a source of energy. That happened because we didn't listen to customers. And so we have to mass produce small reactors because that's what customers actually want. And when the US regains its ability to iterate on nuclear technology, the future of energy changes.
There are actually 52 nuclear reactors built at Idaho National Laboratory in 21-year span. The last of which was 1977, and none since then. There are no advanced reactors. Everything was done in the 1950s and 60s.
Nuclear really got sidelined by the environmental advocacy groups that pushed misinformation on the general public.
We just continue to ratchet up regulations for a variety of reasons, including some of the public perceptions around nuclear. It's my opinion that we regulated nuclear out of business because we made it too expensive.
The current state of the energy grid is not great, and it doesn't say, hey, America's ready to build. We need energy for everything, and the grid we're building on right now is mostly created in the 60s and 70s. Technology has changed a lot. Society has changed a lot, and it's starting to show that what we're building on is aging. About 45% of Americans have experienced one outage in the last year. For a business, that can be catastrophic. It's a really important thing for folks to grasp that when you turn the lights on, it's from the 60s. We kind of run just at the median of the power we need. And on some days, in many states, we actually dip below what we need from an energy perspective. To really innovate, to unlock prosperity, we have to get above the line of what we need. We have to give ourselves room to do all of those. And that, from a national security perspective, is what will allow the US to be the US we all grew up dreaming about.
Countries that rely on other nations for their energy have strings attached. When there is conflict and energy sources are relied upon from other nations that have become adversaries, it can cause an entire country to shut down. To be able to have your own energy independence provides energy security as well, and that is exactly what nuclear power can provide.
I founded Radiant after working at SpaceX for about 12 years. One of the things I worked on was this Mars challenge, which is to make life multiplanetary. In order to really make that happen, you need to be able to take Starship to Mars and then make fuel on Mars and bring it back. And to do that, you need power. And so I looked into solar power on Mars and found that was really challenging. And then I looked into nuclear power on Mars and found that was the only way. I didn't want to found a company. I had to do it because I knew that the mission that SpaceX itself had could not be achieved unless we had nuclear, and I wasn't able to work on it. So it forced me to found a company.
Doug builds in machines and systems, and I build in people and companies. The more we got into it, we kind of discovered together the impact that we could have.
What we want to be doing is building reactors, not reactor buildings.
You gotta dig a massive hole in the ground, and once you start digging a hole in the ground in the US, you have no idea how long or how expensive that project will be. Costs are very hard to control. Once you make a nuclear reactor in the ground at a site, that site is a radiological site. for forever. Customers are not super excited about that. When Doug was designing the product, he said, well, all of these things must be true. And therefore, I have to make a product that is above ground, that is movable to where customers need it, and then also that they don't have to deal with waste on site. And so you got Kidos. It's a transportable by land, air, and sea microreactor. And after a customer has used it, we take it back to our factory site in Oak Ridge, Tennessee, and refuel it. We handle all of the parts of the nuclear industry that customers didn't want.
I always tell people when I talk about the Kidos reactor to think of a diesel generator. Anywhere you'd see a diesel generator, you could bring in a Kidos reactor. They're roughly the same size, except you don't have to refill it every 8 hours. It gives you power for 5 years, and it provides much more power. Many, many times more power than a diesel generator, and you can daisy chain them together. So you can bring in 4 Kidos reactors and power a small city. You could power a very large data center. You have all kinds of capabilities that come around from something that really can be put on the back of an 18-wheeler. That kind of power generation and making it transportable has never existed before. That's why I say there's actually use cases that we haven't really even imagined yet.
One of our units is 5 years of power in a box that just gets delivered. Fits in a few parking spaces, and then whenever you want us to take it away, we take it away. Which hasn't really done before. It's only possible if you make a size about 1 megawatt, right? Make a small enough reactor, you can do this, transport it there and back again, sort of trick, and take the fuel back. And so you have like no nuclear strings attached. You can just have clean power. So for national security, we also don't know where we might need power sources to be set up. And so if you need to rapidly deploy AI, you need to rapidly deploy drones, you need to rapidly put something somewhere, it needs to come with power. And if you're not on a grid, you need to bring the grid with you in a box.
When you're building a commercial product, you have to have the same desire to lower customer friction as Apple did with the iPhone. With nuclear reactors, that might sound wild, but it's an absolute necessity. We have to control all of our costs inside our factory, and we can't put any of that burden onto our customer. We can't put any of the burden of the construction on site, the interconnect onto them. We really need to make it as simple as make a reactor, it shows up, it plugs in, you get power.
If you can change that dynamic to factory build, you take those uncertainties off the table. You might translate a little or some part of those uncertainties to building your factory and your entire process, but once you've done that, you're done. If you're successful, then you can just start turning out that commodity. And your customer then has a much lower, potentially even almost zero uncertainty in their cost, and their on-site activities are just completely reduced. That is a tremendous promise of factory-built nuclear.
We're taking this unit to the Dome, which is this 80-foot diameter structure that was built in the 50s. It actually had the experimental breeder reactor in it at Idaho National Laboratory. Since 2020, we've been on target for going there by 2026, and then we'll go critical. The system is designed to go to over 700 degrees Celsius, and then we'll run for 150 hours continuously.
That dome was going to be torn down and ultimately was repurposed for this purpose that now enables Radiant to be the first company that comes in that was selected through a competitive process. Radiant was selected, simplistically speaking, the maturity of their technology, the maturity of their planning, the benefits of that test are going to be in terms of a full power test over a significant period of time, which will be our first full power test at the laboratory in a very, very long time.
When Radiant first started talking to INL about testing in the Dome, we were, I think, somewhere around 20 employees. And we said, 4 years from now, we're going to build a commercial prototype of our reactor and we're going to test it in that facility. And they said, well, we're going to have to build out that facility too, and you're 20 people. And so there's a lot of faith and trust and process that we put in the way as we were developing both the product itself as well as the full test campaign, the test facility. And really through all of that is where we developed the partnership.
The executive orders that our president signed in May of last year accelerated everything. And so that is a critical component that has helped make this possible.
As a number of companies race, nobody has turned on a new commercial microreactor ever before. And Radiant's going to be the first to do that.
design, build, and execute on safe reactors, no one's going to buy them. We are a company that needs to make money. We are in the United States. Making money is pretty important to sustain, to build out the full mission. If we were cavalier in how we built even the prototype, we put the future at risk and our customers at risk in a way that is almost completely perverse to what the mission's goal is.
What's happening in nuclear right now is unbelievable for somebody like me who has spent my entire career in nuclear. I believe we're in a full-on renaissance.
The world is watching, but the world is waiting. And there are many companies that want to deploy, but they just don't want to be first. And Radiant is willing to be first and has the courage to take those calculated risks and then demonstrate to the world, not only the public, that's an important point, that you demonstrate to the public that this can be done and it can be done quickly.
I love the idea of one nuclear reactor per week just coming off of a production line. We'll be able to just plug in a nuclear power module to any of their designs and then proliferate our use of power in space. Maybe make a city on the bottom of the ocean. Maybe put a reactor at that high up camp on Mount Everest. Just put power in places that today seem totally crazy and impossible.
Nothing we're trying to do at Radiant is considered reasonable. We're an energy company at our core. We want to change society's relationship to energy. You don't do that by doing a slightly different version of something that's always been done. You have to come out with a kind of ridiculous stance and really drive in that direction to accomplish it.
Nuclear microreactors that are mass-produced, that are reliable, in the most wild scenario, enables humans to leave the star that we were born at, the sun, and go to other ones. And it's imperative that we do it as a civilization.